Welcome to this video tutorial about how to change settings in MATCH-T so that morphological data has a bigger impact, especially also measuring form lines and single points in forest parts, so that we can extract with the morphological data and the feature-based matching run the ground better in these difficult areas. And this is the goal of this video. We will need to make changes to the control parameter files. The control parameter files are the files that you can select here from the strategies. So these files here, they are stored by default in C program data, Trimble photogrammetry, then depending what version you are using. So this video here is showing with version 11. Then in photogrammetry 11 you find strategies 11.0. Of course in 12 you will find strategies 12.0 or 12.1, and then info surface generation. And when we go to this folder, we will find exactly these strategies that we have seen from the drop-down list here. And we will need here to make a manual change to the grid width, which is the grid width of the internal used raster. By default, if we open this one here, we will see that there are here at the grid width 4 stars, and then again 4 stars, which is an automatic value that we place. So we are taking here into account the ground sample distance and so the pixel size, and then we take it approximately something around 30 times. So whatever one pixel is representing, then here an absolute world coordinate distance, so whatever here 7.6 feet or 30 feet or 20 centimeter or 50 centimeter would then be used for this one project, because then the next project we have a different ground sample distance, then this value will vary. But we can also here override this value with a physical fixed value. And in my example, I will showcase you for this project that I use here, which makes sense. So I made a copy of the default CNT, and then I did make a change. I changed here these 4 stars to 30.0, 30.0, which means in this case 30 feet. It's in this case here mainly the reason in X and Y, but we are using squared pixels. So in that case 30.0 will be our internal grid, and this makes also sense. I would leave it really this way in this part. So this value is the value of our internal raster, and this one is used to set the heights of this internal raster cells. One cell will then make an evaluation of our automatic measurements. And we want that our manual measurements will have a strong influence. So therefore we will make this internal raster larger so that many automatic measurements can be influenced from one single manual measurement. And then we can make all these internal height settings here to a lower part influenced by our one single manual measurement. And so that's why we enhance it from these typical 4 stars, which are something around 30 pixels, and I enhance it by the factor of 4, so which will be something around 150 times the pixel. I think maximum wise we can only run it up to 130 for the internal check, but let's leave it with 130 times pixels so you are on the safe side. And therefore these 30 times pixel, you can also find it in the log file by default. So in my project that I was running by default, without changing anything here, this was the setting. Yeah? So as I mentioned, something around 30 pixels was the average grid width of this internal grid, and this represents around 7.65 feet. And then we enhance these 7.65 times 4, which ends up then around 30 feet. And that's the entry that we will place here into our control parameter file, as we can see here. So 30 and 30, which is exactly this value. Secondly, also, I have set the parallax threshold to the minimum, which is 4 pixels. This is the value that you can see here in the parallax threshold settings. So here I reduced this. Even I was using terrain model undulating. I have set this to 4 because I want that my morphological data is the main component to model my terrain in this area, and that's why I have also changed this in the CNT file. Yeah, so this is also CNT file entry, just that we are aware. And these are the two settings in the CNT file. We save it, and then we have this new CNT file. Please, 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 as I don't want that you cause trouble with other projects, try to use for your CNT a name which indicates that this is really just for this one project. Of course, if you have other projects where you have a same ground sample distance, it would work, but be aware, if it not, then this can cause a lot of trouble also for the other projects. Second thing is the weighting of the morphological data. So if we want that our morphological data has exactly for these difficult areas a much stronger influence, we need to reduce the standard deviation to an absurd small value. Not because our data is this accurate, but let's make it a little bit a thumb rule. That means if we reduce this value to very small and we divide it through our default settings. So if you hit this button here, let's show it here. By default, this is 0.67. So in this case here, let me here go back and showcase it here. So 0.67, and then we enter 0.001. Then we get a factor of 670. And this is approximately, this is really a thumb rule, but if in one internal grid cell we would have around 670 automatic measured points, then one single manual measurement could still be strong enough to make an influence on these other measurements, which means if all my points are on top of the trees, 670 raw data points, and in this one cell I have one manual point, which indicates no, we are here at the bottom of the trees, then this one point would influence the other points, and in this case here drag down the internal raster. And because the internal raster is then on the ground and we have a very minimum parallax threshold of 4 pixels, then the points on top of the tree are not anymore valid measurements. They will be eliminated, and we will remain with only a few couple measurements, hopefully a few measurements. We're able to measure through the trees to the ground on the bottom, and these ones will remain, and they will be our input data for our final result. Same thing also has influence on form lines, so both of them would work in the same way. So if you use instead of single points form lines, then here activate this and put the standard deviation here to a very strong value. Okay, so I hope this makes sense. Let's do this now in a practical work. Go to your CNT files, make a copy from your default one. So in this case, copy and paste. Then rename this new one into your special, this case, name. go into this new CNT file, change these values to the real world 130 times your GSD value. So I will use here in this case 30.0 and then again 30.0. My parallax threshold is here already on 4 because I went on the user interface and changed it beforehand. By default it would have been 8, but I leave it here to 4. Then I save this one here, close it. Then I will not need here this one anymore here. If you have MATCH-T open like me, this is bad because I think, let's see, yeah, you need to have MATCH-T closed. So in this case, you don't need to close the applications master, but with restarting MATCH-T, then the CNT file is now available. So we can go here to edit, and now we can see here this new CNT file available to be chosen. Then of course you need your morphological data, and let me just quickly show in DT Master what morphological data we have. So here we go. We have here an exclusion areas for the buildings. We have break lines, which are here the borders of the street on the left and right side. We have here single points, these red dots here in the forest itself, and we have also form lines. I will only run it with the red lines, so I will use the data set in this way. So just these points, and when we take a look at these points, they are 3D points. So here, let's here not overestimate this whole thing here. And when we make here a shaded view, then they influence here this terrain in some way. It's going a little bit here downwards here in the center, which is exactly this part. So here it's a little bit higher. Here is a little bit lower. There's a water body part here in the bottom. And these points, they are inside these trees. And without the mass points, we will get a wrong point cloud here for these trees. They will be on top of it. And with these new settings, we will then here be able to give these, with these red points here, to influence these internal grid cell. And therefore, we will be closer to the bottom of the ground. And then the measurements inside here will be dragged down to the bottom. So let's use this data into MATCH-T, and let's swap back to MATCH-T. So we have here our area. I imported here a polygon for this small area, so I did not need to run the whole thing. So I have here this clipping on. And then we go into edit. In the morphological data, as mentioned, I will only use the surface points. I will not use the form lines. We will use the break lines. We will also give them a strong weight. And that's it. So this is about the weighting. In the advanced, I didn't change anything, just using the polygon, which was my boundary here. I used default settings for the optimization. And in the basics here, I didn't change anything here except for using now this strategy. So I will go here with our new one, this XXX. And therefore, we will use here now the larger internal grid spacing. And we will also use the 4 pixels of our parallax threshold. So there we go. We say OK. Then I go out here, and then we will save it and process it. We will see now here that the processing starts. For the errors messages, you have to be, it's only an information, so in the wrong tab, so don't be here scared. It's just that we don't find 2D exclusion areas. My exclusion areas are 3D exclusion areas because I measured the building rooftops as my footprints, and therefore, but they are only used here for exclusion. That's it, we are done, And then let's go to DT master and take a look at the result. And in DT master, we will load our result, and we will also import additionally one more time our DXF file with the morphological data, just to prove that these data was used to influence it. So here, let's load the data here in, and let's import additionally also here the DXF file that we just used here. And there are in my input folder, morphological 4. And we have here the break lines, which are my break lines, the exclusion areas, which are my exclusion areas, the form lines I did not use, so I will not import them, and the mask points I will bring in, and the other things I will ignore. And then we will here finish this part, and let's here activate the contour lines. And we can now, when we switch this off here, see that there are no trees now here on top of it. Let me here switch off my interpolation for this part here. So if we take a look here, let me switch also off this shading here. Let me see the points, and let me here make the points here yellow. Let's hope that you see it yellow. So let me perhaps hide this one here. So here we are. So, and we see now interpolation for my measured MATCH-T result is activated. So this is now only based on my MATCH-T result, the interpolation. The morphological data that I also imported now here at the moment is not used, but if I activate it here, then we see here that this data strongly influenced here this result here, and we can see also the same thing in the profile view. So when we take here a look at this data, then let me here set on the shading. Let's make this here only perhaps 5 times shaded, and if we switch it off, here we go, if we switch it on and switch it off, then we see here that there are almost no differences between here these parts and the other ones, and therefore these points have now influenced. Let us also perhaps zoom in closer, that we really can see here how good here they fit. Let's perhaps also make automatic ones here, and then we can see now here how these points are influencing here in a good way our result. So everywhere the yellow points are close to it. They're of course not pitch perfect to its neighbor point, because it's an internal raster that is then used to filter out the wrong measurements, but this is exactly what we want. So I hope this helped you to get with your morphological data in tree areas where we still can see a little bit through it on the ground, to get really good ground results out of it and to influence it this part. I want to add here a little bit an extra, but this is normally where the video could already end, so you don't need to continue. I want to show you a little bit with the MATCH.status file, more in depth, even more, so that you have perhaps a better understanding. So this is now the tech geek stuff. So let's, in this case here, close DT master and let's go back to MATCH-T. In MATCH-T, you can activate a status file. In the documentation, you can find here how to create it. So I will not go through it. After you created it and you start MATCH-T the first time, you will see in the menu here an icon, which is the status file that you can access. And in the MATCH.T status file, I want now, especially just for this one topic here, getting to the bottom of the ground and also visualizing more here, show you a couple of parameters that are helpful. One, and you will find them all in the chapter 3D point cloud. And I already have tweaked a little bit around, so you will find one parameter called DTM shift, but there's here a plus, slash, minus DTM. So I will just make it here to minus DTM shift, which will then again consider the lower points as my preferred ones as my final result, even if my internal raster does not include manual measurement of my morphological data. Yeah? There's not everywhere in every cell, I don't have everywhere manual measurements, so therefore in the other ones also again the lower points are the preferred ones, which will also help us to get to the ground better. Secondly, there will be a lot of, I want to create here additionally my measured data, not my final raster, and this is by activating here the PTS FBM LSM to output. So I will not get now here in the end my 6 feet raster, but I will get really the measured data, which is an irregular point cloud, which will help us to see how here our morphological data influenced now our processing. And still, because it's a lot of noise which can also come with it, I will smooth it strongly and just here make my raw, these matched FBM points, I will filter them, smooth them, so it looks in this case here nicer in this case. Yeah. Well, I played with 3, I will put it only on 2. So 0 will be not much smoothing, 1 a little bit more, 2 more, and 3 very strong. So let's try it this time with these settings. Then I save it. And because this match status file is in the folder where my project is located, these parameters, they will be used when I run my process. So that means I will now rerun this part here again, but this time here, just to see the differences, I will here output it into, no, I will override it. We already have seen it in the video, the other one. So I will just override it this time with these settings now. Again, my CNT file will still be used, so I have my larger internal raster grid cells and also my 4 pixel parallax threshold, but additionally now I will not write a grid with 6.8 feet, but the original measured feature-based meshing points, and also they will be smoothed. Okay, so let me just double check if I have everything right. Yes, this should be fine. I say okay. Then I will save the project, hit run, and it asks me, do you want to override it? I say yes to all. Let me also check if I have anything open. Yes, I have something open here. So I will close here this log file, and I will also check here, not important for this part here. So what else do we have here? Just to be sure I'm not using something that blocks my calculation. Okay, that's fine. Yes to all. And we will now see that also in this part, we will see that the match status will here mention, we will smooth the data. We will output here the matched feature-based matching points. We will try to stay down on the lower point cloud as preferred. And therefore, this is now additionally happening. So let's close MATCH-T. Let's open DT Master, and in DT Master we want to take a look at this result. So here we go. Surface, same boundary because I overwrote this one. Then let me here navigate to this part, and this time we see now an irregular point cloud. And even more better to see is now when we take a look here in the stereo part, and we will just take a look on the left image. No surprise, exactly where these trees are, we have this lower density of these points. Mainly because the internal grid is now here below, and therefore all the measured points that existed here on top of these trees, they cannot be used because we only use a 4 pixel parallax threshold. So these measurements disappear, and these other points, they were through the matching algorithm, somehow he was able to get a little bit lower, deeper to the ground. There was a stereo model that allowed him to get somewhere a little bit more deeper part this. And if we take a look now here at this point cloud here itself, then we can see now already here, if we don't overlay it here, that these points are really all on the ground. And there are no trees here on top of it. And just to prove the whole thing, I will now also rerun the whole thing now without our CNT file, our larger internal grid part, and also without the MATCH-status part. So just by using a standard setting, so that we see how this will then come out as a result, so we could compare these two things. So let's go one more time back to MATCH-T. But before I do it, just to prove it, shaded proof, contour lines. So we see, yeah, no jumps here. Yeah, just that we are safe. Yeah, it's not that there's some wrong visualization. So it's really nice on the ground. But let's jump now back to MATCH-T. So here we go. I go back to my MATCH-status. I will now again deactivate these parameters. So I will not use a -DTM shift. I will not smooth here this whole data. I will also not output here the point cloud itself. We could have done it too, but just to be sure, nothing is used here from this part here. And secondly, also, we will go here into the edit, and we will now not use the XXX, but I will use the default. As we have seen, the default is exactly like the XXX, but now with these 4 stars in the grid size, and therefore we don't use now here a larger part of this part. And also for the morphological data, I will use here the default settings. Typically we always say only a third of it. So this is the common parts that we mention here to use here, and therefore we can apply it. And let's go here back to everything else, and that's it. That's fine. So I can say, okay, activate this part, save it. Let me double check if I have any files open. I have the CNT files open, but just to be sure, okay, we see here in the default, everything is fine. Let me just close it to be sure. And that's it. Save it, run it. I will overwrite again the previous result, say yes. And this time we see there are no MATCH-status informations included. So it finds the file, but nothing is activated, so nothing is listed here. And then after the process is done, we will then review it in DT master. So let's save it, close it, and then last run now here for us, taking the view and seeing that now the points will be on top of these trees. So therefore, take a look here, and here we are. And if we switch it on, then we can now see here that in this area that we have looked here, we have now here the trees on top. If I zoom a little bit out and make it hide colored, we can see it here. This is the terrain, and we have here on top of these parts. And also when we take a look here in stereo, and we only take here the left image, and we take a look here at the contour lines, we can see exactly how this jumps off where our trees started, which also includes the morphological data. Yeah? The morphological data was used. We see these single points here. There's a yellow point here. Here's a yellow point. Here's a yellow point. But because the internal cell size is so small, it will not influence further away to it. And also the parallax threshold in this case here, and the weighting. Yeah? So the weighting is not strong enough to have a large, big impact to many points of it around it. And therefore, increasing the cell size by a very large value, increasing the weight, helps us here to reduce these matched feature-based matching points, which then will be used to generate this raster and to put our terrain nicely back to the ground. So if you survived till here, then you really use MATCH-T, and then I hope this helps you to understand better the morphological data, the internal grid size of the DTM, and the filtering, also how the parallax threshold can have an impact, and also how you can smooth the data to make it look still very nice. Enjoy this video, and hopefully this helps you to become better and get better results with MATCH-T in inpho. Thank you very much for watching and have a nice day. Goodbye.